Okay, we're here at go2math.com looking at some calculus. Let's go down to, I believe it's Rolle's theorem, and we are going to be doing number 2, which I need to label number of those things. What do we got going on here? Let's see, it says determine if Rolle's theorem can be applied. If so, find all values of C such that f prime of C is equal to 0. Of course, here's the graph of g of x. And so one of the things that's stated in Rolle's theorem, first off, g of x must be continuous in the interval, and it is. And it must be differentiable in the open interval. So that means if we had parentheses right here, well, in other words, we don't include 5 and 13, but it must be differentiable, and obviously it is. And then it states that, well, if g of 5 is equal to g of 13, and that's what these red dots, so this is g of 5, this is g of 13 here, and if they are both equal, then we can say that there exists a C such that, well, anyway, it says it's up here, we can plug a C into the derivative and get 0. In other words, we're going to end up finding a minimum. This is where the tangent line, right, is 0 right here. So let's write this down and then head over to the whiteboard. Okay, so we're going to move on over and write some of this stuff down. Alright, so we have g of x is equal to x minus 9 squared plus 17. And we're on the interval, the closed interval I should say, between 5 and 13, including 5 and 13. Alright, so this has got to be continuous, right, on the interval, and it must be differentiable on the open interval. When I say open interval, this is what I mean by that. Okay, but this is a polynomial, and it's differentiable everywhere. So we ain't got to worry about that. Let's just cross that out for a second. Okay, so let's do this. We want to find g of 5, plugging 5 in. And so I will just tell you that that is 33. Let you calculate that. And then we're going to do 13, plugging 13 in for x, and that's also 33. So we can use this theorem because this is true right here, that g of 5 is equal to g of 13. So therefore there must be, there's got to be at least one c such that this is true here. Okay, so let's find that c. So let's take the derivative. We got g prime of x is equal to 2 times x minus 9, right? And then derivative of 17 is 0. Now we will go ahead, set this equal to 0, and we're plugging c into the derivative. So where there's an x, we'll put a c. And as you can see, that it's pretty easy to see that when c is 9, 9 minus 9 is 0, we get 0. So there is our c. Okay, pretty simple stuff. All right, man, you're going to be a calculus expert before you know it. Okay, so let's go up here. Let's make sure the script is, what did I say it was, 9? Yeah, make sure the script is correct. So as you see the form I'm writing it in, I'm like, gee, you can plug 9 in and get 0 and see that. But first we got to make sure, right? We got to make sure we can use the theorem. Okay. Alright, so we want to head on over, and I might chat with you there at the forum. Okay, bye.